Hamza Farouk. Hamza Farouk is joining us all the way from Nigeria. Is that right?
Yes.
What? Yep. So we're all around the world here. It's wonderful to have in-person and online speakers from all over the Python community. So with that, I'll let you take it away.
Okay. Good morning, good afternoon, or good evening, wherever everyone is around the world. I'm Hamza, an AI enthusiast. I must stay here before the presentation starts. I'm no AI expert. I'm just an enthusiast that interested in the field and have been doing some learning basically by myself. Today, I'm going to discuss RAG system and an unusual approach in which I used to get better retrievals from the RAG. I'm gonna start sharing my screen now. Uh, Go. Okay. Okay, here. If you could see my screen, this is the topic retrieval in a RAG system. Basically, I'm going to start with defining what a RAG system is and what makes it so important. Before then, traditionally, most LLMs, most large language models are used by just, you take an input text, you feed it to the LLM and you get an output. The popular use of ChatGPT, you just give it an input and it responds with an output. But as we have all known, the response you get from an LLM, it's only based on the data it has been trained on. And if you ask it questions regarding what it hasn't been trained on, it's most likely going to hallucinate and give you responses that are not exactly accurate. So now here comes the main thing. What if I have a personal data? What if I have some company's data or some personal information I would like to use with the LLM? How do I get my personal information to the large
Can
language
we,
model and
sorry,
get?
can we ask if you present the full screen?
Okay,
So it's,
please, yes.
thank you.
Okay. So I was saying, what if I have a personal data I would like to feed the LLM and ask it questions regarding it? Well, there are basically two approaches to that. You could either take the long route of fine-tuning the model, and by fine-tuning, you have to adjust the model's weight. And honestly, it is more technical and requires some heavy computational resource. It is not very straightforward. Or better still, you could use what they call the retrieval augmented generation, which is a popular RAG system. All this does is actually provides a context to the LLM and which it used to answer question form. Just for a brief demonstration of what I mean by that, if I have a text like this, a text in this form, and let's assume this is my company's data. What this RAG simply does is that I'm going to take this text of mine and I'm going to use it as the input to the LLM. Say, this is a search passage. My name is Hamza. I do this, I do that. If I were to take this, copy this, and feed it to, let's say, ChatGPT, paste it and run it. Because I provided this context to the LLM, you should be able to answer questions like, what is my name? My name is Hamza. So the whole essence of a RAG is finding a way to provide this particular information to the LLM before asking it questions for it, before querying it, if that makes sense. And because this is just providing context to it, you could actually run any large language model which you desire underneath. It is not specific to LLM and it requires way less computational resource. So now in the next few slides, I'm going to go through the step-by-step process of the RAG system. We are going to start with picking the entire document. Now I have a document, I have a PDF, a company's data of 12, 15 page. The first process is I want to take all those documents and make it into a single text. Afterwards, those texts is probably going to be more than the context size of most LLM. So what I want to do is actually split those texts into several chunks. After I've split it into several chunks, I'm gonna have to convert those chunks into embeddings. By embeddings, I mean just some vector representation that have some semantic meaning. Because the LLM in the back end does not exactly understand English language or whatever language is running. It has to convert it into some number to be able to work with. So afterward, whatever question I have to ask the LLM, I might have to also convert it into numbers. Then I'll do some comparison. I have my query. I have the entire document in chunks. Which embedding of the query is most similar to that of the chunks? So with this, when I'm able to do this comparison, I'll get the most similar document from whatever I have, and now I'm going to use that document as the context. There's a lot of jargon here, and I'm going to explain this process bit by bit. And in fact, I have a code I wrote in order to demonstrate the process. So the first part of the code is, this is just installing some important libraries that we use it for this. I'm going to use PDF by PDF film in order to extract the document and run this. For the demonstration, I'm going to import one of my personal document. Let's see this. I'm sorry about that. Okay, this is a document that I intend to. This is going to be synonymous to say my company's data. This is the entire document. I want the LLM to be able to answer question form, which represent the first step as I showed here. This is the entire document. The next step is for me to actually split this document into several chunks. And I have to do this process because the entire document most likely is not going to fit into the LLM. I'm going to exceed the context size. So how do I do the splitting? How do I convert it into, how do I do the splitting? Okay. Splitting the document actually could be done in several methods. I could either split the document into character size. I could say the entire document should be splitted by 30 words. After every 30 character, split it by 30 characters. So each of the document is splitted by 30 characters, 30 character, 30 character. Or I could do sentence splitting. By sentence splitting, I could actually split the document by sentences. Or I could also use a recursive text splitter. By recursive text splitter, it is going to try to split the document first by paragraph. If it's not able to do that, then it split it by new line. If it's not able to do that, then it split it by individual words. I'm going to show all this process hopefully before. So here we are. This is the entire document I have here. The demonstration I want to show here is splitting it by character. I have the entire document here, and I would like to split it by character. And I'm going to use a chunk size of 35. What that simply means is that after every 35 character, it's going to try to split this whole document I have here. Let's run this one and show. Okay, so this is splitting the document by every 35 character. From just visual inspection, it is obvious that this kind of splitting is not very useful because it's actually splitting the words in between in words. You're not getting complete sentence, but this is actually one of the ways you split. A more efficient type of splitting would be splitting into sentences, and I'm going to demonstrate it using the spacey library. Because the spacey library is actually an it's an NLP library, and it kind of understands English language, so it's able to split it into sentences. We are going to see here. Should have done this one. I'm sorry, it's taking some time. Okay, so here I'm attempting to speak the entire document by sentence. So it assumes this is a complete sentence, then this is a complete sentence. And as you can see, it's actually stopping on a complete sentence. So this is one of the ways we could also split. So the whole idea of splitting is the whole entire document cannot fit into the LLM. We need to do some sort of splitting. And finally, the last type of splitting I would like to show here is the recursive splitter. What the recursive splitter does is it actually attempts to split the entire document first by paragraph, but as long as the paragraph does not exceed the chunk size I have specified here, the moment it exceeds the chunk size, then it's tries to split it by new line. If it's not able to do that, if it exceeds this chunk size, then it splits it by new line, and so on. So it first attempts the paragraph, then a new line, then white space, and so on. Okay, so I'm gonna try to split it here with a chunk size of 100. So rounded and rounded. Okay, here it is. I've been able to split my document into this. So back to the slide, we are here. So we are here. We have been able to split the document into different by different categories. So here we are. We have our entire document. We've been able to split the entire document. But as I said earlier on, the LLM does not understand English language. It has to convert it into some kind of vector representation in which you understand. And the whole process of converting the text into vector representation is what they call embedding. So we're going to try to split our chunks of document into embeddings. And that is, okay, here we are, converting our splitted document into embedding. For this demonstration, I'm going to use cohort embedding. And first of the last document I splitted, the recursive, this document I've splitted here, I'm going to convert everything into embeddings, and like I said earlier on, embeddings are just numerical representation of the data. Okay, so all the recursive text I splitted earlier on are now into their vector representation. And this vector representation, actually, they contain some semantic meaning. What are kind of similar, say, for example, I have cat, I have kitten, I have paw. Because they're kind of similar and share the same context, they have similar vector representation. So this is the third process, converting the splitted document into chunks. Here we are. We've been able to convert our our document into chunks. What we need to do next is we actually take our query, whatever question we intend to ask the LLM, we actually have to convert it also into embedding. That will make the fourth step. And why do we need to do this? If we don't have it in an embedding, there is no way we'll be able to compare the document. So the whole idea of a RAG is we want to get the most relevant context in order to feed to the LLM. So we are going to convert our query also into embedding and do some sort of comparison to get the part the part of the document that is most or that is closely related to the query asked by the user. Okay. Okay. So here is our query. What is the name of the author? And I'm going to convert the query into embedding, like I said also. And here we are. The query has also been converted into embedding. So the next step is we have the query as an embedding. We have the entire document chunks as embedding. We want to do some kind of similarity to get which part of the document is most relevant to the question asked. So here I'm doing a similarity score with using cosine similarity to see which part of my document has the highest embedding. So all these are the entire document I splitted with the recursive splitter is actually splitted into 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 6 times 4. It's actually split into 24 chunks. So for each of the 24 chunks, these are the probabilities. This is 0.27, 0.3, 0. Like that. So each of our documents, so each of these values we're seeing here represent the probability or the similarity to the query asked by the user. Okay, it's speaking about embedding, and this is similarity set. Let me go back here. Okay, now we've gotten each of the probability or each of the similarity of all of the documents. Now we are going to use that to index the most relevant document. Okay, and from and from the most relevant chunk, it actually giving me that this chunk is the most relevant chunk from the entire document, or from the entire chunk that most or closely relates to the question I have asked. So the whole idea is getting a chunk from the query that most relates to the question we have asked. Then now picking this answer that it has responded to and using it as the context to the LLM. Okay, but very quickly, the LLM, this approach actually has two major problems that while I was testing it out, that I realized, and this is what brings me to the topic, the retrieval. I noticed that whenever I use a large chunk size from the recursive retriever, it doesn't actually pick the most relevant document. Yes, it goes and pick a document, but the document I retrieve from it is not or is not the most closely related to the document in the chunks. And when I use a smaller chunk, the information that I get from the LLM is actually not usually enough. I'm going to show this. If I have this question, what is the author? What is the name of the author? And I use this, not this. Okay, and I use this sentence embedding. The sentence embedding only have a couple of words, just artificial intelligence development contract, this and this. If I use this as my query, and if I use this for the similarity search, and it actually responds with the most similar document, each of this sentence does not provide enough context in most cases to answer the question correctly. And if I decide to use a larger chunk size with this recursive text splitter, say that of 300 or 400, whenever I run it with, whenever I do the similarity search, it most of the times does not pick the most relevant document. So how do we solve this problem? If I use a large chunk size, I don't get the most. The similarity accuracy is really poor. And when I use a smaller chunk size, I don't have enough context for the LLM. So that brings us to the title of our topic, which says the retrieval method. And what this simply means is, instead of using a smaller chunk and not getting enough context, or using a larger chunk and not getting enough similarity accuracy, I I do the retrieval is being done in two steps. The first retrieval keeps the chunk small. You kind of use the smaller chunk in order to get the most relevant document. Now, when I've gotten the most relevant document with a very high accuracy, I'm going to use the document that has been retrieved as the new query. I'm going to convert the new document that has been retrieved into embeddings, and use that document to get the most relevant from a larger chunk of data. Why this is effective is because the document that is being retrieved by the first retrieval is actually a part of the document. There's a very high chance it is most likely going to look for those similar words in a larger chunk, and this larger chunk has more context in order to fit the LLM. I'm going to try to demonstrate this in code. Okay, if you have this question, what is the author's area of specialization, or let's say what is this? And I've converted this into embedding in this case. So what we are doing with this two-step retrieval is, first of all, we're going to use the sentence splitting or the sentence embedding, because the sentence has a high chance of getting the most relevant document. We split all the excuse me. We split all the document into sentences and we embed them. That's what the first two lines are doing. The second line attempts to use this query, what is the auto specialization, and gets the most relevant document from these sentences. So at this point, the most relevant document in this case is the document that best answer this question, even though it doesn't have enough context because it's just a simple sentence to answer the question, but it has given the response. So now we use a recursive retrieval that has a larger chunk of say 500. This has way more context. Then we use the document which we have retrieved. We use the document which have retrieved as our new query in this case. Then we use we use it as the new query in this case. Then we use the new query to look for the most relevant from this larger chunk of data, this recursive text splitter, which is a larger chunk. Then we have a received data that is most relevant and has a more comprehensive context to the question we asked the user. Okay, now throughout this process, we've been able to take our entire document, split them into embeddings, split our query, do them into embedding, and at this point we've been able to do the double-step retrieval, the retrievals method. So at this point, we are assuming we've gotten the most relevant document with the most context. So all that is left is to provide this to our LLM and use it as our query. And how does this look like in code? It's quite straightforward. Install this. We use a prompt template for this. Say you have some information provided, use the information to respond to the user's query. In cases where you don't have enough context to respond with I don't know. Do not make any assumptions. We use this as our template. Then okay. Okay, then we feed this into the LLM and okay, with this, the AI is able to respond. The author's area of specialization is this and specifically and this because it has enough context from the larger chunk. Smaller chunk has been able to provide the most relevant documents in this case. And that brings me to the end of the presentation. So just a brief recap. The whole idea of a RAG is to be able to provide enough context or to provide a context in order for the LLM to respond to. Whenever we use a smaller chunk, you tend to get more accurate response, but you don't have enough context. If you use a larger chunk for retrieval, most likely you don't get the most similar document retrieved. So the two-step retrieval or the retrievals method is simply doing the retrieval in two steps. It uses the smaller chunk to get the most relevant document, then it uses the response it gets from there to get a more context. It uses the second part of the retriever to get more context. Then it takes this and feeds it to the LLM. And in order to test it out for the public, I actually built a demo in Hugging Face, and I have the link here for anybody that is interested in testing. I want to thank you for your time, and if there is any question, I would like to respond to it. Okay. I want to stop sharing my screen at this point. Thank you.
Big round of applause. Thank you. That was a great overview of a retrieval augmented generative system. Thank you. Anyone have any questions? There's a bit of an echo here, sorry.
Yeah, I wanted to ask, when you searched for big chunks versus little chunks, was it just that you got absolute higher similarity scores as your maximum similarity, or were they better separated from one another when you picked small chunks to search? Like, were the similarity scores more different? Like, was it easier to find one that was the best?
Okay, if I'm not sure if I understand the question correctly. Can you please come again?
Yeah, so the question is that you can put all of the results, the cosine similarity scores, you can put them in order, right? And that gives you a
Yes.
ranking for which is the best match. Did you notice a big change in rankings, or did you notice a bigger change in just the absolute scores, or did you find like bigger distance between the first and the second rank with smaller chunk size search?
Okay, I observed that the smaller chunk actually had better similarity than that of the larger chunk. It has a better similarity number for each for the most relevant document than that of the larger chunk.
Okay, thanks.
Hamza, just
Yes.
an idea. So you're doing something interesting. You're saying, okay, I'm having trouble locating because of the size of the chunk basically affects whatever results I'm getting at the end, and affects accuracy or whatever, it affects other things. And therefore you're doing it in two levels. Did you think about feeding the same document in multiple levels of chunks, like chunk it out, once according to sentences, once according to words or whatever, and like different levels of chunks, and just feed it again and again and again. Just take the same document, split it, and then add to those split things and more things that are split in coarser levels, and then once more in coarser levels, and then ask the question. Did you try that, or?
No, I didn't try that, honestly.
Okay, no,
I just noticed. I didn't
it
try
might
that.
improve the results from the first time, because then it has a larger selection, and then all of those things that look similar kind of compete. And then the LLM might return. I'm saying might because I haven't tested myself, but it's just an idea. Because basically what you're saying is that you're saying to the LLM, okay, give me something similar in this little, when everything's chopped into little chunks. But then you're asking it, okay, from what was returned, where it was located, more or less. Kind of. It's not exactly, because it goes to the LLM and does lots of things. So I would try this. Maybe it will improve things on their own. It will take more resources, maybe, but maybe it's worthwhile trying.
Perhaps.
But another question: you're using LangChain there, correct?
Yes, I'm using LangChain.
Did you try other RAG systems? I know I played with Lambda Index. It has very interesting results sometimes. But
Okay, the whole idea of using LangChain is just for the prompt templating, most especially in this case. I'm not using it for the similarity search. I'm using cosine similarity for that. It's independent from LangChain. So, and I'm using the LLMs. I'm using Coho for the embedding, and I'm also using Coho as the AI model. So the whole idea of LangChain here is just for the prompt templating majorly.
so
So
you're
it
not
might not really.
you're not using
Hmm?
LangChain for the LLM or for the RAG plus LLM. So what library are you using to run the RAG and the LLM together?
Okay, I'm running them in different phases. For the retrieval, I'm using just the normal character splitter. It's kind of independent from LangChain in this case. Then for the similarity search, I'm actually picking it from sklearn. Yeah, I'm using an sklearn matrix, which is also
Scikit-learn.
yes, scikit-learn. Then for the embedding, I'm using Coho embedding. Even I'm importing it from LangChain, but I believe it's independent of LangChain. You could actually use it without LangChain.
Okay.
And I'm also, so I don't think that might really make a big difference, because the only thing LangChain is doing independently here is actually just for prompt templating. Every other thing could be done independent of LangChain.
Okay, so the templating and all of this is LangChain is running. And which LLMs did you choose? I think you
I'm
used
using-
OpenAI.
No, I didn't use OpenAI. I used Coho. I used Coho's chat model, Chat Coho.
ChatCoho. Okay, I'm not familiar with this
Yeah.
one. Okay, thank you. You answered my questions. Thank you.
Okay.
Any other questions?
I think that might be it. Let's give you another quick round of applause. I know it's 1:40. He's a trooper. It's almost 2 a.m., right?
Yeah.
Well, thank you very much for your presentation.